I'm so happy you're here for Chemistry Week 4 Lab. This is where you get the hands-on learning. Okay, so in class this week, we talked about the states of matter. We talked about liquids and solids and gases. So that's what our experiments are going to be on. So the first thing that I want you to do, and I always tell you to do, is get your scientific method and experiment observation sheet. Okay, if you don't have it, push pause and come back. So the first lab that we're going to do, the question is, will water take up more or less space when it is frozen? So I want you to think about that. Will water take up more or less space when it's frozen? So what I have here is a beaker and there is water in it. So I want you to think, do you think when I freeze this water, it's going to get more dense and compact or less dense and expand? Go ahead, push pause, and write down your hypothesis. Now the materials that you need are really simple for this. You'll need a container, and then, see, my container is marked. Yours does not have to be marked. I just have mine marked. If yours is not marked, you can have a Sharpie. All right, so a container, a Sharpie, water, and you can put food coloring if you want. And if you want, you can have a lid on it because it's going to be in the freezer. If you're afraid you'll spill it. So those are the materials. So a container, water, a Sharpie, and you'll have to put it in a freezer. So the steps for this experiment is, first you get the container and you're going to fill the water up to a particular point. Mine, since I have it marked, I have it at 100 milliliters. And my hand is not completely flat, but my counter is. So I made sure that the meniscus, the lowest portion, was at 100 milliliters. So with yours, it's probably not marked. You can take a Sharpie and trace a line up to where the liquid goes on your container. So I've filled in the water, I have it marked, or I've read where it's marked at, and then the next thing that we're going to do is we're going to put it in the freezer. I'm going to write in my observation results, I'm going to write that where I filled my water up to in my container to 100 milliliters. You can write that you filled your container and made a mark on your container, okay? And then when we come back, we can compare it to what we have written down. So make sure you write down your observations. So I'm going to go ahead, I'm going to take this water, I'm going to put it in the freezer, and when I come back, it's going to be completely frozen. So you can go ahead and stop this video and come back when yours is frozen, and I'll see you then. All right, I have my frozen water, and let's see what's happened. If you remember, I filled this up to 100 milliliters, okay? And if you look, it is now above that. It is even above 110 milliliters, okay? It is getting close. Yeah, that's about right there on 110 milliliters. So what happened? The water froze and it didn't become more compact and more dense. It became less dense and it expanded. That's why it went from 100 milliliters up to 110 milliliters. To me, this is absolutely amazing. So typically when you have a liquid that goes to a solid, it becomes more compact, it becomes more dense, but not with water. And this is really important. So if you have any body of water, like a lake or pond, and it gets really cold and freezes, it becomes less dense than water, so it's able to float. And that makes it where lakes and ponds are not freezing from the bottom up, because if it did that, all the fish, all the life in that pond would be dead, okay? Instead, it freezes, it floats to the top because it's less dense, and then it actually creates a barrier. So it helps to make it where it's a little bit less cool under the ice. So I want you to go back, look at your hypothesis. Were you correct? Were you not correct? It doesn't matter if your hypothesis was right or not. What matters is that from experiments that you are learning, okay? So now we're going to get ready for our next experiment. I'll see you there. All right, it is now time for the second experiment. So as I always say, go ahead, get your scientific method and experiment observation sheet. If you don't have it, push pause and come back. But if you do, let's continue. So with this new experiment, we have a different question. And that is, can we make ice cream with milk, ice, and salt? And is salt important when making ice cream that way? Okay, so there are two parts to this experiment. You're going to do one part with me, and the other part I'm going to do, and you'll be observing alongside me. So what I'm going to do is put up the materials, and you can push pause, go get your materials, come back, and do the experiment with me. All right, hopefully you are back and you have all your materials. I have mine here, so I'll change to my lab cam, and you can see I have a Ziploc bag. It already has my, I put 5 cups of ice in here. You could do anywhere from 3 to 5 cups of ice. So the next thing that I want you to do is get some salt. So I'm going to open my bag, and I'm going to put 3 tablespoons of salt into the ice. So I'm working on 1 tablespoon, okay, 2 tablespoons, and 3 tablespoons. Okay, I've put that in the ice. I'm going to mix it up. And you can seal this and put it aside for now. Next, we're going to get the smaller Ziploc bag, and in this, you will be adding the milk. So I have my half cup of milk. There's my half cup of milk. And then you're going to add 1/4 teaspoon of vanilla. So here's my 4th teaspoon of vanilla. That is in there. All right, and so the last thing that we're going to add to it is the sugar. So I'm going to add 1 tablespoon. Let me clean this off. I don't want salt in here. I'm going to add 1 tablespoon of sugar. It's hard for you to see. I'll put it to the side. 1 tablespoon of sugar. And I have put that in my Ziploc bag. Now I'm going to seal this up, and I'm going to mix it up. So here I have it. It's mixed up, and now I'm going to take this bag. I'm going to place it into my bag of ice and salt. So let me switch views. I have my bag of ice. I've opened it up, and I am putting in the smaller bag inside the big bag of ice. All right, you're going to want to make sure both of these bags are sealed up, and you're going to mix up this bag. The idea is that you want to get all the ice around the milk mixture. So go ahead and mix it up. And this is going to take about 5 to 10 minutes. Before you go off, hold on. I'm going to do this project too. I'm going to do the project that has no salt. So I've already mixed up the same mixture as the other bag, and I'm going to place it in my bag that just has ice, no salt, and I'm going to mix both the bags up, And so it take about 5 to 10 minutes. So in 5 to 10 minutes, come back here and we'll look at our results. I'll see you then. All right, I've been mixing both bags for about 10 minutes. And then the next thing you want to do is take out the small bag and go rinse it off with some clean water, just so you're not getting salt into your milk mixture. So go do that and then come back. Okay, let me show you the results that I got. So I have 2 bowls, and the gray bowl right here is going to have the milk mixture that was just placed in the ice. It did not have any salt. Okay, now this blue bowl has the milk mixture that had the ice and the salt. Let's see if I can get it out. Are you seeing that? It looks like ice cream. We can see that there is definitely a difference between the 2 milk mixtures. They're the same milk mixture. It's just one was mixed with ice that had salt and the other was not. So there is a difference. So to answer our question, yes, we can make ice cream when we have ice, salt, and milk. But no, we can't make ice cream that way if we don't have salt. Let's take a look at 2 glasses of water that have ice, water, and one has salt and one does not, to see what's going on. I got 2 glasses of water, one with salt. This is the one with salt, okay? You can tell that there's you can see little clumps of salt on the side of the glass. And then here's one without salt. So I'm going to get my handy dandy thermometer and put it in here, and we're going to see what the temperature is, okay? So I'll turn it this way so you can see it. It is definitely going down. This is in Celsius. I'm used to Fahrenheit, but this is in Celsius. And it's approaching 0 degrees Celsius, which is 32 degrees Fahrenheit. That's the temperature that water freezes at, okay? So it is going down and approaching 0. Let me warm this up. I'm going to warm it up with my hands. You'll see that dial going right up from the heat on my hands, okay? And then I'm going to place it in this cup that has the ice and the salt. So let's see where it goes here. It is about -3 right now. Now it's about -4. It's going to, now it's about -5. Can you guys see that? I will hold this up. Do you see how it's -5? It might be hard. My camera might not be focusing well. There we go. Okay. So it is definitely colder. The ice with the salt is definitely colder. You could see that the ice that had the salt, it had a lower temperature, a lot lower temperature. And with different liquids, they have different freezing points. And with milk, it happens to have a good bit of fat. And because of the fat, it has a different freezing point than water. So when you put milk with ice, that temperature is not cold enough to get it to freeze at all. But when you put milk near ice that also has salt, the salt makes it where the ice starts melting, and it also lowers the freezing point for the water. So the temperature is a lot cooler from putting salt on top of the ice. So that's what we learned. We learned we could take a liquid and we could make it a solid, but not all liquids have the same freezing point. The freezing point for milk is different from the freezing point of water. So in order to get milk to turn into a substance that is like ice cream, it has to get a lot cooler than 32 degrees Fahrenheit or cooler than 0 degrees Celsius. So that is why we add salt to ice. It lowers the freezing point of the water and it makes it a lot cooler. I hope you guys had fun with this experiment. And as I always say, if you have any questions, please do not hesitate to have your parents reach out to me. And this is absolutely amazing. Perfect. I'm going to go eat ice cream. Bye, guys. Have a great week. I'll see you on Tuesday. Happy learning.